here is the same information given in the question as a diagram. So we've got a radius of 6 centimeters. So here and here, each of these are a radius. And then we've got this arc length, which goes from here to here. That is 2 pi. We also have this angle here. This is the angle that is subtended at the center of the circle, and this angle is given as theta to ease our workings. Now we're trying to find the value of this angle, so we're going to use the fact that the arc length is equal to r theta. Well, r is the length of the radius and theta is the angle we've got here measured in radians. So here we've got 2 pi equals 6 theta. So therefore theta equals 2 pi by 6, or simplified, that is pi by 3. In this example, we're asked to find the area of the shaded region. That's this bit here. This is actually called a segment, this blue part here. Well, to find the area of the segment, we're going to do the area of the sector, which is this bit here, minus the area of the triangle, this bit here, AOB. The area of the sector, as long as we're in radians, let's write this down, area of the sector equals a half r squared theta, where theta is in radians. You've got to be in radians for this question. But we know we're in radians because the angle's given as 2 pi by 3 as opposed to it being in degrees. How do we work out the area of this triangle? Well, the area of the triangle is equal to a half AB sine C. But look, A and B are going to be the same value, aren't they? So we end up with a half r squared sine theta, where again theta is in radians. So make sure you're in radians mode on your calculator for this question. So the area of the segment, we're going to do the area of the sector minus the area of the triangle. So we've got the shaded area equals a half r squared theta minus a half r squared sine theta. Writing it out like this will make the problem solving more efficient because we can take a factor here out, can't we? A half r squared. So we've got a half r squared brackets theta minus sine theta. Well, let's work this out then by putting in the value. So we got a half 5 squared brackets 2 pi by 3 minus the sine of 2 pi by 3. And to 3 significant figures, putting that in a calculator will give you 15.4 centimeters squared. But you've got to make sure your calculator is in radians mode.